Okay, so on the take-home final, question number 7 has a question about a quadratic, and I'm not going to answer that exact question, but I thought I'd use this chance to talk about quadratics in the context of your not just the take-home, but the whole final that you're going to have for honors pre-calc. So I'm going to answer a few questions for this hour, and hopefully more than just one person will ask a question. If you find another topic you want to talk about, it doesn't have to be on the take-home. It could be anything we've had this semester. You can ask about it. All right. So this quadratics area could even come up in the middle of a log question. Actually, I'll keep your life a little simpler. All right, take a look at that. This will help you review logs, and it'll help you review quadratics. And in a moment, I'll get around to answering the thing you really wanted to know. All right. First off, do you remember me saying that you'll never solve a log problem unless you get the two logs put together? You have to condense them. All right. So take a moment, put those two together into one log. Log base 2 of x times x plus 4 is equal to log base 2 of 14. Now that I've got it down so there's one log on each side, now, since they're the same base, it isn't really that these are canceling, but it's kind of like that. It's that the things on the inside, the arguments, must be equal. Right? So now I've got x times x plus 4 is equal to 14. Now with quadratics, you want to set them equal to 0, and then if you can factor it, you should. X squared plus 4x minus 14 equals 0. I just did a quick little subtract 14 from both sides there. Now, can I factor that? 7 times 2 makes 14, and the 7 and the 2 aren't going to make a 4, so this one won't factor. So you try to factor it, because that's the easiest thing. The next thing I'm going to run through, just because I know this would probably help you somewhere, is that the discriminant, do you remember the discriminant part of the quadratic formula? X equals negative b plus or minus square root b squared minus 4ac all over 2a. That little formula right there has this key little element. Paying attention? Because this is the part you really wanted. All right. That little part right there is called the discriminant. What if that part is negative? What would be true about my solutions? There would be no real solutions. What if that part was equal to 0? What would that tell you about your solutions? There would only be one solution. So if you wanted just one solution, you'd say, well, I want to set b squared minus 4ac to be equal to 0. But that's not what you really wanted. Okay? If you want two solutions, then what does b squared minus 4ac have to be? Bigger than. Could it be 0 or just bigger than 0? Bigger than 0. Not bigger than or equal to. That's two different things. All right. Okay, so now that's what's called the discriminant, and it tells you how many solutions you're going to have. All right. Last piece, since I'm in this general neighborhood, is this. This is one of the most forgotten formulas. Negative b over 2a. What the heck does it tell you? The vertex. Yeah, vertex is x. The x of the vertex. So that means if I have this, and I know it makes a parabola because I'm smart enough to know that, you know, things with x squared and make parabolas. Or if it's x squared, meaning the biggest degree is 2. Because I think if you have an x squared in the middle of a longer thing, it doesn't make a parabola. But this one would be a parabola. Well, its vertex is a really special spot. It's its lowest spot, minimum, or its high spot, maximum. And that can be found with the negative b over 2a. Now, you may note it just says x equals. So that's just the x of the vertex. And then you put it back in, whatever that answer comes out to be. Let's just do it quick. Negative b would be negative 4 over 2a, and a is 1 here. Okay, so 2 times a is 2 times 1. So that's negative 2. X equals negative 2. That's a line. It's called the axis of symmetry. Some kid said that earlier this year, and I liked it a lot. X equals negative 2 isn't the vertex, but it's the line that runs through the middle, and then the vertex has to be on that. So this vertex has to be at negative 2 comma something. Well, how do I get the rest of the vertex? You just stick the negative 2 back into the equation. I'll go back in here and here. So I may as well finish the deal. Negative 2 goes in there and makes 4. Negative 2 goes in here and makes 2 times negative 4 makes negative 8. Negative 8 plus the other one was 4 makes negative 4. Negative 4 minus 14 is negative 18. So final answer, I should write that bigger, negative 2 comma negative 18 would be the vertex of this parabola. And that reminds you of a whole bunch of formulas you need to know about quadratics. And that started as a log question. All right, so back up to our log question we had in the first place. What were we supposed to answer? We're supposed to answer what x is. Well, have I solved for x? None of the things I actually did yet solved for x. I found the vertex, that's neato, but it's not the solutions. What are the solutions? They are these guys. So again, you can't, if you can factor it, you should. We figured out we can't factor this thing, so we're going to use the quadratic formula. And that's x equals negative b plus or minus square root, etc. So I'm going to now put in 1 for a. Hold on just a second here. I'm going to put in 1 for a. That goes here. B is 4. That goes here and here. And C is negative 14. And don't just assume, ooh, you just made it negative underneath. No, actually, it's going to be 16 minus negative, which means plus 4 times the 14. So 40, 56, and 16, 70. Square root of 70. So this is negative 4 plus and minus the square root of 70 all over 2 times 1 is 2. And if you simplify that down, that would be your answer. I know that's a bit of a pain, but that's my answers. By the way, what if one of them is negative? Then we got to look back at this and say, if you end up with a big negative number, do you get that that would not be okay? Any negative number, in fact, because look at, it's an argument of a log. Don't forget that in pre-calc, a lot of times your answer is that there is no solution. So I get 2 solutions. One comes out negative, that one doesn't work because you're not allowed to have negatives in the argument. All right, there's a pretty big general topic that's something that's covered on the pre-calc final. There's so many things. I can't cover it all, but I can answer your questions. Any other topics off of this take-home final that you have in front of you right now? Any other topics that come to mind? Yes? I'm guessing that you've checked it twice before you asked me, so you're probably right. So you're saying that this underneath here, this was 16, square root of 16 plus 40, 56. Yeah, you're right. 72. Thank you. That should have been 72, not 70. Good catch. You're right. 72 can simplify now, but either way, it's going to have a square root in it. A little bit. I just like to be right, so thanks for letting me know. Okay. Topics. Yes. Problem what? 8. Okay. Let me just talk about clearing fractions. Do you remember on the top 20 where I tried to teach you how to clear fractions? You multiply by the denominators. Does that ring a bell? What happens when I multiply by the denominator here? I multiply everything by 4, does it fix all my problems? No. Multiplying everything by x doesn't fix all my problems. So what should you multiply by? Pay attention, please. Don't talk back there. All right. You should multiply by 4x. When you do, it clears your fraction, and cool, that's gone, and ooh, it made an x squared. This cancels, and it made 12, and this makes 60x. Now, if I subtract that, you always said things equal to 0. X squared minus 60x plus 12 equals 0, and then I can solve it. See how it's much easier to solve now? All right, so that's been a theme since the beginning of the year. If you have a fraction in the problem, clear the fractions. See, no fractions. Now it's just a quadratic, and you can solve it just like we did the other quadratics a minute ago. Quadratic formula always works. All right, so that's the essential thing that you probably need to figure out in that problem. Okay, any other topics you'd like to talk about? Absolute values, rational functions where you have poles in them, one of those? Okay, so with the rational functions, let's say you had what's this thing's domain? What's its vertical asymptotes, horizontal asymptotes, and holes? Okay, so domain. Domain is like, what can you safely feed this function? Would you agree that there's one thing that would not be safe? 4. So you want to say everything works except 4. I would write it on a number line, because remember how those notations go? There's all different kinds of notations, and it just can't be 4, and there's a number line way to write that. I could put that in set builder notation or even interval notation. Interval notation is pretty common. It goes like this. But either way, that's my domain. Everything works except 4. How about the vertical asymptotes? The vertical asymptotes are whatever makes the bottom equal 0. So x equals 4. The horizontal asymptotes, that's the bigger on bottom, bigger on top, same on both thing. Okay? If it's bigger on bottom, here's the little rules. If you're smart, you're taking notes unless you already know these. Bob, sob, bot, and bigger on bottom, y equals 0 plus whatever's on the outside. Same on both kind, y equals a ratio of the lead coefficients. And the last one is the bot kind, and that's no bots. No bot. There's no asymptotes for that kind. All right? So what is this? Is this bigger on bottom, bigger on top, or same on both? It's about the power that's on the x. This one has an x to the 0. Sorry, I can't even, that doesn't make any sense. That has an x to the 1. This one has an x to the 0, if you want to think of it that way. So it's bigger on the bottom. So this one's a bob, so it's y equals 0. Just a quick test to see if you were paying attention. Don't say it. Write down what you think the horizontal asymptote is. Is it bigger on bottom, bigger on top, or same on both? It is not bigger on the bottom. It is degree 2 on top, degree 1 on the bottom. That is bigger on top. And if it's a bot, what's the rule for bots? There's no bots. And 0 is different than none. And that's kind of weird. But 0 would be if it was a bob, bigger on the bottom. Okay, this one is a bot. So there are no horizontal asymptotes. All right, I'm going to change it a little bit. Now this one's going to be x to the 3rd on the bottom. Now what is it? It's a bob. And so what's the equation? Y equals 0. And last but not least, what if I put a squared here and I put a 3 and a 5 there? New problem. Would you agree this is a same on both? What's the deal for same on both? Ratio of lead coefficients. So y equals what? 3/5. That's how you do horizontals. I also called them horizontals because they have a y, you know. All right. And then how about the vertical asymptotes? Go back to the original one I had up here. What's the vertical for this thing? Yes. What about -4? X equals -4, y equals -4. That is a vertical asymptote. The way I would say this is, if you just say -4, you have left it open that it could be x equals -4, or y equals -4, or just a scalar number, -4, which isn't part of a graph. So this, it's a big deal. You have to label it. Don't just give a number. There's almost no answers for this kind of question where you'd ever just have a number. You're almost always saying x equals this or y equals that. All right. And then how about a hole? Do you guys remember when that happens? Something special happens? You get how the thing on the top and the bottom are going to cancel? That makes a hole. What is the number that creates the hole? -4. So -4 creates the hole, but that isn't a point on a graph. It's -4 comma what? Well, you go stick your -4 back in this function and see what you get. And what do you get when you put in -4? 16. That's where the hole would be. All right. I said I wanted to have a lot of work time, so I'm going to stop there and give you a lot of work time. There are a few of you that may have looked on Skyward and seen your score and said, you know what, I could really use some extra points back on that test because I can't do a retake, but I can do corrections. Now would be the time. That's all I got for you for today.